farmer wishes to build a fence around a rectangular pasture and divide it into two areas as shown. They have 600 meters of fencing. Find the total area that they can fence, the maximum area they can fence. Okay, well, area of a rectangle is no big deal. We know that's length times width. So this whole distance here, end to end, is our length, and that, of course, is our width. And we'd like to take a derivative for this and set it equal to 0 and solve it, but the usual thing has happened. We have two variables, so we need to clear one of those out if we can, which means we need another equation that relates L and W. Well, we have this 600. Could probably do something with that. There's 600 meters available for all the material of all this fence, not just the perimeter, but also this divider in here. So that means when we do this fence, we're going to have an L up here and another L down there. So we're going to use 2L worth of material making that. Also, we're going to have a W there and another W and yet another one, total of 3 W's. And all of that together can be no more than 600 meters. So if this were just a rectangular box, this would look like 2L plus 2W. It would be a perimeter like we're used to seeing in rectangles. But because of this extra line, we get an extra number here. Now, can we solve this for something like L? Yeah. We can take the 3W to the other side. La 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 la. We can divide everything by 2. There we go. Of course, if you want to solve this for W instead of L, that's perfectly fine. You'll end up with the same answer that I'm headed towards. But if you do, you're going to get a 2/3, which is a non-terminating decimal, and I didn't want to get involved with that. I'm happier working with a 1.5 that's relatively neat. So that's what I had in mind when I solved this for L. I saw an opportunity to make things a little easier on myself, and I went for that. So L it is. Anywhere there's an L in this equation, I'm going to put 300 minus 1.5 W instead. Here we go. A equals L times W. That cleans up to 300 W minus 1.5 W squared. Now, if we want to optimize this, we know we want to differentiate it and then say the derivative is equal to 0. That'll tell us where the top of the hill is. It gives us dAdW equals 300 minus 2 times 1.5 is 3W to the 1, and all that equals 0. So that means 300 equals 3W, which means W equals 100. And if you want the length, this formula is all set up to find it for you. The length is 300 minus 1.5 times, we know what W is now. So the length is 150. So according to math, this pen should be 150 by 100. That would give us 15,000 square meters of area, which we claim is the best you could possibly do. And for material, it uses 150 plus another 150 is 300, and then 400, 500, 600. Perfect.